Okay. So, chapter 4 involves application of derivatives. Okay, so we did like all the different derivatives in the last lesson. Okay. So specifically what we are going to focus on is what are called extrema. Okay, also known as extreme values. Okay, so I'm going to say the word extrema, but all I'm really talking about is mins and maxes. Okay, so have you heard of the word absolute maximum before? What's an absolute max? Like absolutely the very highest of the possible, the whole function, right? And the absolute minimum is like the lowest spot of the entire function. Okay, that's not new information, right? Okay, well that's part of an extrema. Okay, so this is kind of an interesting theorem. Okay, and it probably isn't necessary that you write it down, but it helps with some of the little details. Okay, so it says that the extreme value theorem. So if f is continuous on some closed interval, put your phones away. There you go. Okay, so if our function is continuous between some a and some b value, then our function is going to contain an absolute maximum and an absolute minimum. Okay, so if it's contained, there's a max and there's a min. That's it. Okay, there's some fancier way of writing that if you want to copy that down. But if it doesn't make any sense to your brain, I wouldn't write it down.
If I didn't write down anything, if I didn't write stuff down. Anyways, I would not have any notes if I didn't. Yeah.
Okay, write down, this is what I would write down. If your function is contained within a closed interval. Does that make sense to your brain? A closed interval? Like there's a beginning and an end.
So not a problem.
Right, exactly, not a problem. You're right, because they go to infinity, right? Within a closed interval, then there's an absolute max and an absolute min. Okay, so an absolute max and absolute min are pieces of extremas. Okay, you can also have local mins and maxes. Have you heard of local mins and maxes before? Okay, what's the difference between an absolute max and a local max?
Local is like maximum is like the highest.
Okay, you're on the right track. I wouldn't necessarily say it could be at the end, but it's a hill, right? Somewhere in the middle, probably. It's possible that the local min and local max, like you could have many of them, right? Like if we were looking at kind of, let's say, a sine function that kind of wiggled like this, right? You'd have this absolute max, and it comes down, and you could have a local min. And it could go back up and have a local max, local min, local max, and then an absolute min. See what I mean by that? Okay. So just so you know, relative maxes and mins, you see that little highlighted piece? You've heard that before, relative. Local, relative, those are interchangeable. Depends on the textbook that you're using. So just be aware that you might see that notation as well. Okay, so here's a little graph of this scenario where we have local versus absolute. Okay, can you see the absolute maximum?
Yes.
Bam, it's right there at the very highest spot, right? Okay, so this is our absolute highest spot. Can you see our local max? You see a local max?
Yeah, I do.
Yeah, right? This one happens to be right here at the top of the hill, and there's also one right here at the very end point. Oh, that's a minimum. I mean, that's a local minimum. So we have two local minimums here at the bottom of the hill. Okay, and then the very lowest spot is the absolute min. Pretty easy. So all of those things are called extremas. Okay, so when I say let's find our extremas, we're looking for maxes and mins. Okay, so how do we find them? So let's say we don't necessarily have a graph. We are going to use calculus to find them. You are doing the wrong reaction. You should be cheering. Woo! You might not always be able to graph. All right, so all you have to do to find your extremas is simply take the derivative, the first derivative, and set it equal to 0, and that will help you find what we're going to call critical numbers. Critical numbers. Okay, so a critical number is a number where you could have potentially a max or a min. It's just an important piece of information. Okay, so shall we?
So it's the first derivative set.
First derivative set equal to 0. Yep. And we're going to find critical numbers by doing that.
I know.
All right, so here is our first example, although it says example number 2. Okay, so we're going to find the absolute. Now notice this is absolute, the very highest, the max, and the very smallest value of x squared on our interval between -2 and 1.
All right, hold on.
What are these numbers called?
Example.
Critical numbers. Okay, so our first step in doing this is finding our critical numbers. So how do we find the critical numbers?
First derivative
set equal to 0.
Good, I'm going to take the first derivative, which happens to be what, by the way? What's the derivative of my function?
2x.
Good, 2x. So now I'm just going to take that and set it equal to 0 and solve for x. So where do I have a critical value? At 0. So I have a critical number at x equals 0. Okay, now before I progress, what I have to do is I have to figure out what are they asking me for. Okay, they're asking me to find some values, a max or a minimum value. So what are they trying to get us to find? What value do you think they're talking about? If we draw this parabola, oops, that's not highlighted. Okay, so we're finding this parabola. We found this critical value when x is 0. You see how I plotted that? Oh, interesting. Okay, if I'm trying to find an absolute max or absolute min, what do you think I'm looking at?
This isn't a closed interval, but no, wait, is it?
I'm looking for the y value. So when they're referring to a value, we're finding a y value. You might write that down because that is important. The answer that you're looking for is a y value. So if I'm looking for a y value, how do I find y values?
Horizontal asymptotes.
That's how I find slopes of 0.
Okay.
What's that? Into which function?
The original.
Into the original. Very good. So all I'm going to do is I'm going to take my critical numbers, which by the way are going to be also including my two endpoints, plug them into my original, and see which comes out as a max or a min. Okay. So I'm going to take my lowest possible critical number, which happens to be -2. Do you see my little bounded region? I'm also going to plug in 0, which I found to be a critical number by deriving. And I'm also going to plug in the highest endpoint to see if that could potentially be a max or a min. Everybody okay with what numbers I'm testing? Okay. So I'm going into my function. So I'm looking at -2 squared would give us 4. And then 0 squared would give us 0. And 1 squared is 1. So which one gives us a maximum value? Okay, so we have a max at the x value of -2. So 4 is our max value. Which one is our minimum value? 0. So 0 is a min at the x value of what? Which number did I plug into the function? That's 0. Okay, so notice the way we're writing our answers. The value we're looking for is the y, and we're going to tell it which x makes that y happen. Good there? No, that's pretty much it.
So 4 is the y.
Yep, 4 is the max y value on that interval.
So like it would be the point. Would it be the point of 4 and 2?
So if they ask you for a point, yep. So if it says in the directions, find the point of the max or the min, then you would list it as negative 2, 4, yep. So it depends on how they ask you the question. Mm-hmm. Ready for one more? Okay, same idea here. Not too much more complicated. Okay, so we have same idea. We're finding the absolute max and min of our value. So if they're asking us for a value, what kind of value are we looking for? We're looking for a y value. Okay, where do I start? Okay, so I need to derive this function. Okay, what is the derivative of x to the 2/3? 2/3 x to the negative 1/3. So I'm going to quickly rewrite that because I have a negative exponent. So what's going to happen with that x? It's going to go into the bottom. Okay, so I'm going to take that and set it equal to 0 to find my critical number. So how would I solve this equation? How do I get that denominator piece out? Close. So all we're going to do is multiply it. I don't know if you said that, but I didn't hear you. So I'm going to multiply the 3x to the 1/3 to the other side, right? So what happens when I multiply 0 by, who cares? You get 0, right? So what is going to be left? 0 equals 2. Does it? Okay, so for this one, we don't come up with a critical number, but there is a critical number that we have to worry about. Okay, the other scenario that we have to worry about is anything that makes our derivative undefined. Okay, so if I find a derivative, anything that makes the denominator 0 becomes a critical value. Okay, so if I look at this equation right here, is there any value that would make this denominator, or excuse me, this function undefined? 0, because x cannot be 0. Okay, so for this one, our critical number is at x equals 0. Okay, so make sure to check for undefined values as well. Okay, so what are the 3 numbers that I'm going to check for on this one to find my max or min? -2, 0, and 3. Correct. Anything that makes the denominator 0 is also a critical value. Anything that makes the derivative 0 or undefined. No, I would not assume that. No. The functions that we've had have been very simple functions, so they've been 0, but we can do a harder one. So I'm going to take this and plug them into our original. So I have -2 to the 2/3. Anybody know what -2 to the 2/3 power is? Leave it in an exact form, please. Do you remember that the 2 is the exponent and the 3 is the root? So what's -2 squared? 4. So it's going to be the 4 or the 3rd root of 4.
Okay, what? I didn't know.
So the top number, we square it. The bottom number is our root. Root.
Oh.
Exponent. Remember this?
Oh. Yeah, but would it be a -4 then, though?
-2 times -2 is positive.
But it's not. Oh, but the exponent squared. Oh, no. Yeah.
Okay, what's 0 to the 2/3 power? 0. Okay, and what's 3 to the 2/3 power? So we're going to square 3, good, and take the root of it. Cube root of 9. Okay, so tell me, what is the maximum value?
I don't know.
3? Or would it be?
The cube root of 9, which is not 3.
Well, I was
That's the
just
square
saying
root.
Close.
Oh, the x value of 3. I got you. Okay, so our cube root of 9 is our max value at the x value of what?
3.
At 3. What is our minimum value?
0.
0. The x value is 0.
You have to talk about some local stuff.
Not in this scenario because it's just asking for absolute. Okay, should I... Ooh, so here's one thing that I do want you to write down. I think that this is... let's do this one. You should write this down. So those 3 steps are finding critical numbers. Critical numbers. Okay, so finding critical numbers. You set your derivative equal to 0. Okay, you find any value that makes our derivative undefined, and then you also test your endpoint. So those are the critical numbers that you're plugging into your function. What are the numbers that you're testing?
Is there an easier way to say interior?
I would just say you could just say your derivative equals 0. That's fine. You don't probably necessarily need to find interior. The endpoints are the 2 from the given interval. Okay, do you guys want to do one more? Maybe a hard one?
No, I'm good.
You need to do a harder one. It would be like on the worksheet. If we get to the worksheet, half the time there's problems that are way harder than what we did.
The problems on the worksheet are harder.
No,
Let's see if I can find one.
I have faith in us.
A completely different topic?
I just don't want to.
Let's see if I can find something.
Gucci, Oh, I have spades in my pocket.
What's the relative minimum amount?
Dude, big ass. Where are you shooting?
Where am I shooting? Okay, so here's a question, same idea. The directions on this one says, find the absolute max and min, and then it does say to graph the function, if you want to. I didn't ask you to graph, but same idea here. Okay, so this looks, our function here is a trig function, so apparently those are scary. The interval, maybe this looks scary. The interval just is written in inequality notation. So let's go ahead and try this one. All right, so first thing, what do I do? Good idea. That's a good idea to grab your unit circle.
No, you gotta derive it first.
Okay.
It's negative cosine.
Either of those 2 scenarios would work. You know you're going to use your unit circle, but the derivative is, what'd you say?
It's negative cosine, or just cosine.
Good. It is a straight up cosine.
Then is it negative sign then?
Derivative of cosine is negative
Oh,
sign.
see, I always just forget that.
I always remember it because anything with a c, like if you derive a c, it's always going to be a negative. So derivative of cosine is a negative sign. Derivative of cotangent, negative. Derivative of cosecant, negative. Okay, now what do I do?
Now you.
Oh wow, things got tricky. Set it equal to 0. Okay. So do you remember how to solve an equation with trig? So I'm grabbing my unit circle. Do you have it in front of you?
No.
Maybe you got it mentally now. Okay, so you're looking for an angle, right? You're looking for an angle where the cosine is equal to 0. By the way, what is your cosine? Is it your x or your y?
X.
Cosine is your x. So where on the unit circle is the x value 0?
Pi over 2.
Pi over 2.
And 3 pi over 2.
And 3 pi over 2. Okay, and is 3 pi over 2, whoops, in our interval that we have?
No.
This interval right here?
Wrong. Erase it.
Okay, so because it's not within our interval, it's bigger. 3 pi over 2, that's like 1.5. That's bigger than 5 pi over 6. We don't have to test it if it's not within our interval.
Wait.
Okay,
Wait. No.
say it one more time. So I don't have to use 3 pi over 2 because it's not within my interval. 3 pi over 2 is bigger than 5 pi over 6. Okay, so now we're going to test our 3 critical values. What are the 3?
Pi over 2.
Okay. Okay, so we're working with, remember we're plugging this back into our original, so we're working now back with the sine. So if you're looking at the sine is your what? Your y. So if you go to the angle negative pi over 2, which is straight down at 3 pi over 2, what is the corresponding y value? On your unit circle? You go straight down 1 unit. Anybody else agree with -1? Okay. If I go straight up to pi over 2, what is the corresponding y value?
1.
Positive 1. Ooh, here's a tricky one. Let's see if I can remember. 5 pi over 6. So 5 pi over 6, let's see, would be like right there. So that spot would be a negative 3 pi over 2 and a positive 1/2.
Yep.
So what's the y value there? 1/2. All right, so which one is my max?
The one that's
The second one. Pi over 2.
Second at, good, at the x value of pi over 2. Okay, and what's my min? Good. We got it? Piece of pie.